Welcome, everybody. We're going to be working on Module 1 here tonight and going through the labs. And we're going to start right here with our very first lab, and we're going to begin with a little bit of lecture. The main concept that we're covering in this first lab is how to get stuff to the screen and how to get stuff from your user. So we're going to look at the input and output pieces of working with Python programs. Since we're all pretty brand new to Python, and we don't have a textbook for this course, we have this documentation, all these links here, and this will be very common in all of our units, by the way, as we go through materials. In absence of a textbook, we're using online resources to cover the stuff. Now, what's kind of interesting here is we already did a little example, and I'm going to bring up Visual Studio Code here just to kind of refresh our memory, where we created folders and created a basic little program just to make sure our environment is working correctly. If you need help with that process, remember I have a video in the general information posting inside of Canvas that talks about how to install the IDE and run a little test program like this. But when we start talking about language features, it's kind of a really weird place to actually start, because we're going to go to the comments section of Python, which I think is a very strange first link. So what I'm going to do is I'm actually going to backtrack us out of there and take us up to the top here to the home section of the Python area on W3 Schools. But a little bit of preview on W3 Schools. I know some of you are already well familiar with this site, especially web developers, because W3 stands for World Wide Web. And this website is put together by the World Wide Web Consortium, which is the official standards body for the internet. So in other words, they're the ones who set the rules for the HTML, CSS, and JavaScript languages that all the web browsers follow, and ideally all the web programmers follow as well, and is the preeminent site for those three technologies. And if you need information on any three of those, this is the place to go. However, when you code for the web and often for applications, you learn a bunch of other languages and tools, and you will notice that SQL for databases, Python, which is what we're learning, Java, PHP, et cetera, et cetera, et cetera, et cetera, including C# and a bunch of other frameworks and other weird languages. And really what's happened here is W3 Schools has become a great resource. I think of it as a reference tool for coding. Now, one thing I tell my coders when they're starting to learn is like, oh my God, there's so much stuff I have to memorize. Okay, first thing I will kind of dissuade from your mind is don't bother. Right? That's kind of a terrible thing for a teacher to say. What do you mean? Don't memorize how to do it? Yeah, don't memorize how to do it. Memorize how to find a place that can get the information that you need. Memory on this stuff will come just from repeated action, like the print command, which is the one we're going to do mostly as we start. Is one you will remember because it's so basic, right? But when you get to really complicated syntax on something, you probably will have to look it up, even as a working professional, and there's no embarrassment in that. I mean, sometimes you remember it, sometimes you don't. Knowing where to find the information is the key part. This is an excellent site for doing that. Now, if you guys recall, we just did that little example of Hello World inside Visual Studio Code, but one really nice feature of this website is they have all these what they call try it yourself tools, right? So they give you an example of code, and if you want to play with it, it brings up an internal coding environment that works right in your browser. Pretty cool, I think. So like, for example, I can come over here and say hello Waukesha or something like that, hit the run button, and then it executes right in the browser, and you should see the output there in just a second. But what's kind of neat about this is we'll show you something, then you can play with it to kind of suit your own needs and see how it works, and then you can copy the code and bring it into your own IDE and use it from there. So this is very, very handy, and it's a great tool for learning and experimenting. Pro coders use this stuff all the time to kind of refresh their skills and remember, how does that command work? Oh yeah, all right, yeah, this is a good example. I'll use that, you know. So, and there's no embarrassment in that, but that's basically how it operates. Python is a language that's been around for a little while. It was created by a guy named Guido. If you can look this guy up, he's still around and he's still alive. He had no idea this language would get so popular. Not at all, right? He invented it in 1991, as we mentioned earlier, to automate server tasks. But some of the things that you can use it for, and I will kind of zoom in a little bit so maybe we can get rid of some of these ads, and I probably should use a different browser or ad blocker, but I'm not, so here we are. But some of the things that we use it for is web development, driving the back end of a website, creating software, doing math, system scripting, and by the way, as I mentioned before, primary tool for data science, primary language for data science, and primary language for artificial intelligence as well. For whatever reason, that's what it's become. It talks about what Python can do, and you can read this on your own, what platforms it works on, why to use it, why it's useful, compared to other programming languages, and then of course the little try it editors. They do have on occasion videos here, so if you want, I'm not going to play this during class obviously, but feel free, the material's up there. This is developed by W3, so I assume the content is really, really high quality. Another thing that I want to point you to, and you'll see this in our course shell, is down here on the left sidebar, we also have LinkedIn Learning. And I'm going to open this in a new tab, and this is free to all WCTC students and most of the students in the Wisconsin technical colleges. But LinkedIn Learning is a platform that has a bunch of video courses, and the fact that you can access it for free is pretty darn amazing, because compared to like watching like YouTube videos, these are complete courses, and there's multiple courses developed by very, very high level and quality instructors. So if you want to come in here and learn the basics of Python, you can see, for example, this is pretty recent. It was from April of 2024, basic training. It's a 4-hour course, and it goes through a lot of stuff. If you're doing, very specific aspects of Python, they have courses particular to that. One thing I find really kind of interesting is one of my instructors over at Gateway creates videos for them, mostly like with weird JavaScript frameworks and stuff. But so I know it's a quality platform because he's a quality instructor, so take that for what it's worth. But I'm going to go back to the Module 1 lab here. All right, so please explore those materials. And if you really want to get, deep dive like on some of those LinkedIn videos, go for it. Right. What we're going to do here is they talk about how to get stuff installed. They give you command line stuff. And if you want to make sure that it's installed, they give you some tips here. And they give you examples, right, of how to operate. Notice this is all command line stuff. Now, I'm not saying that this is not valuable, but that's not what we're here to learn today. But if you want to deep dive on it, feel free. People that are already comfortable with the command line, go for it. Yes, you can do all this stuff from the command line if you're really that kind of person. We are going to look at some of the syntax here. So like when we start to put Python commands together, we'll have a command, right? And then the output. And what's fascinating is if you're working from the command prompt and Python is installed, I can just type a command at the command prompt, press enter, and it will execute. Really interestingly, even in Visual Studio Code, after I ran the hello world, I have a thing open right now. I can do really weird stuff like 2 + 2, press enter, and it gives me 4, or print double quotes like wow, right? Press enter. Oh, and it doesn't like that. What did I do wrong? Oh, I know what I did wrong. Anybody spot it? Yeah. It doesn't want me to run this type of command from the prompt, but the point is it's an interpreted language, and I can typically force commands to run. I'm not sure why that one's not running, real frankly. It could be that the double quotes are not correct, but now I am, of course, going down that rabbit hole to figure out why. Okay, so it doesn't like me doing that command from the prompt. So it wants me to do that from the program. But the math it did, really weird, but it works. Okay. Normally at a command prompt, I could be able to run this command and it would work. In Spider, it works for sure. at a regular prompt, provided all the Python tools are installed, it should work as well. All right. So the first lecture topic that we have in module 1, which is kind of a strange one to start with, is a comment. So in other words, a comment is something we add to our code that isn't code. Yeah, that's kind of a weird thing to start with. Well, why? Okay. The why is so that we can add stuff to our code that is non-executing, like notes to ourselves. This is how I put something on the screen with the print command. And I'm like kind of being silly here, but notice how the color is different. I put a pound sign or a hash mark, whatever you want to call it, at the beginning of the line. And then functionally what happens is all the stuff that follows it is ignored, right? It won't execute, but it can be very helpful for writing a program. Like if you're leaving notes to yourself, or you're trying to explain to a different programmer why you're doing something, or what some instructors will also do. I'm not a real big stickler on this, is they'll have you put like your name, you know, I don't know, maybe WCTC, you know, week 1 homework or something like that, and the dates and whatever, so you can like label your work, right? And that's the thing you can do. What I often use it for is just to leave notes for myself. So even when I'm teaching, I'll have code that I've written, and within the code, I write notes to myself. So when I'm teaching, I don't forget to mention something or why I'm doing something. The other thing that you should note is that if I put a command in, I can add a comment to the end of the line. So after the code, and say this is a comment. Now, interestingly, when I execute this, right, none of that stuff shows. You guys see that? So this is stuff that doesn't really affect the program running. It's notes for the programmer. As you will learn, as you kind of get deeper into Python programming, there's some conventions for leaving notes for other programmers. Like if you're writing, for example, a function or an object or something like that, that you indicate what it is and what parameters it accepts and what it's supposed to do. Like you can describe the code, right? And I think all of those things are useful. So these are comments, right? So pound sign and whatever follows is a comment. Right? So they show the same thing. So it can be on its own line, or it can be after a snippet of code. Next thing that we want to talk about is we've already played with the print statement. You can see that basically once we put something inside a print statement, it will output. But we can also prompt our user to enter information. And this is actually kind of cool. So what I'm going to do right now is, because we're going to start getting into the actual lab stuff here in a second, and this is one of the things we have to do, is I'm going to kind of mimic this. So I'm going to do this over in Visual Studio Code. But to get started, I'm first going to create a brand new file, and I'm going to call it mod1 lab 1, right? .py. And don't forget the py. That's how Visual Studio Code knows it's Python. Okay. Mod1 lab1.py. You can call it whatever you want. You want to call it chopped liver? That's fine. Just know what it is. Don't be guessing later and complaining to me. It's like, I don't remember what I called my homework. Well, that's on you. Right? If you put it in the right folder and you name it the right way, it makes it really easy, actually, doesn't it? All right, so here we are in the program, and if you want, you could put your name at the top. So I'm just going to click in here and type my name. And I know other instructors will make you do this, so I'm just doing it for the sake of them. Module 1, lab 1, and you know, whatever else you want to say, whatever else they make you put in there, you should put it in there. But that's a very common thing in programming classes. I'll be real frank. When you turn in your homework through Canvas, I know it came from you. I really don't care if the comments are there. I think the comments really should be for you. But if this helps you, do it. That's what I'm going to tell you. Sometimes what I will do when I'm writing programs is, if I have a set of instructions, I'll move them into the program in the form of comments so that I don't have to flip screens to look at the instructions. They're right there. You know, that's another really good usage for it, right? So, right, this is a comment. So there's a comment. But now we're going to do some input, all right? And all right, so we're going to have to talk about a couple of concepts kind of wrapped into each other here. Normally, when I'm trying to get information from the user, I will use what we call the input function, right? Which looks like this, basically. However, since I'm capturing something from the user, I need to put that input somewhere to be able to use it. So I create this thing called a variable, and don't worry, we'll get into all of what this means in a second. And I'm just going to name my variable username, and I'm going to say equals, and I'm going to move input up onto the same line. And then inside the input box, I'm going to create a prompt for the user. So in other words, this is what will appear on screen asking the user to enter information. So for example, please enter your username. I was adding a space there so that the cursor's not right next to it. And this will capture any text the user types up until they press enter. The moment they press enter, the text from the screen will be captured and stored in this container, right, which is really a spot in memory. It's a named spot in memory that will hold that text. Now, interestingly, once I do that, I can print it out. So for example, I can just print username. Notice, no quotes. It'll take the contents of username, which is what we call a string. That's, you know, things inside quotes, basically, or characters, and it'll just put it on the screen. So let's just try this, right? So this is very, very simple. So I'm just go ahead and hit run here. Right. And notice down here at the bottom, please enter your username. I'm going to do my snarky whatever, right? And I'm going to press enter. It captures that information, right? It captures it here, puts it here, and then I'm outputting it here. Right. So this is super basic, but now we're able to feed information in and put it back on the screen. It's really no small thing. You know, this is pretty powerful and very quickly. Now, let's ramp this up a step because that's kind of boring, right? To like, oh yeah, when would I ever type my username and it would just pop back up on the screen? Like never, right? But maybe I could add a little bit of text here. So notice the double quotes, open and close them at the same time. And I'm just going to say, welcome, comma, space. And actually, I don't need the space here. And then I'm going to put a comma after that. And what this does, and this is the traditional way we do it in Python, the old school way, basically, is this text will appear on the screen. A space will be added after it. And then this symbol becomes what we call a concatenation symbol, or to join strings of text together. And then the username will be added to it and put on the screen. So instead of just throwing the username back on the screen, we'll say, welcome, you know, whatever, right? But I'll do something a little more clever this time. Notice this is currently not saved. You guys seeing that? Because it's a circle. Watch what happens when I hit the run button. It automatically saved. It went from a circle to an X. So that happens every time. All right, so I'm going to say, all right, let's just pretend my name is John Smith and it's J Smith. Right? I'm going to press enter, and now it says, welcome, J Smith. All right, everybody getting that to work all right? This is part of the lab assignment, by the way. How do you concatenate if you don't want a space? Excellent question, because that's exactly where I was going next, right? Like you're reading the script here, right? What's kind of fascinating is for those that are already used to programming, and like, you know, I'm thinking of like a language like C# or Java or one of those other more traditional languages, you can include the space here, but then you switch your concatenation mark to a plus sign, just like you would in those other languages. And that works just fine as well. So And I'll put a little comment here. The old school concatenation, I gotta spell that right. And what I mean by other language, by the way, is like I said, C sharp, Java, JavaScript. I'll do it like this. They use the plus sign instead. If you use the comma, it adds a space after. If you use this approach, you have to force the space. So watch the run on this. So I'm just typing in nonsense, so be mindful of that. But notice I get the same output either way. So we're grabbing input. This is the input function. We're storing it in a variable. Then we're printing it. And notice that we're able to combine what we call literal text. This is literally text inside the print command. And this is variable, but it also contains text. Really important concept. And this is one that sometimes I have to remind even advanced programmers about, that whenever a user is typing something at the keyboard, even if it is a number, it is still text. And it has to be converted to a number in the program to use it as a number for math. And we'll see that as we kind of move forward. You did notice that my spelling mistake was enforced. Did you guys even pick up on that? Yeah. So there's no spell check. There's autocomplete and IntelliSense, but there's no spell check. You can actually add tools for spell check, but not really wise in programming typically. Is everybody getting this to work? Okay, excellent. Let's move on to the next little lecture topic. And that is to store data using variables. Now, we've kind of already been doing it all along, but now we're going to look at a couple of other examples. And what I like to tell people is, as you learn about this concept of a variable, I like to use an analogy often, and you can make, there's many different analogies you can apply here, I suppose. But I always used to think of a variable as a box or a container or a jar. Maybe a box is a really good thing. So when I create a variable, and I think now, if you know another language, I want you to notice a striking difference between a traditional language like C# or Java and Python and JavaScript, which are notoriously loose in their variable creation, right? And this is one of the weird things about Python, because it's so loose, but it makes it so flexible at the same time, and therefore powerful because it's loose. So here I'm creating a spot in memory, and I'm giving it a name. So on the left side of the equal sign is the name of the spot in memory that makes sense to us, right? So I'm creating a box in memory to store information. I can feed in a number, and notice there's no quotes on the number. So this would be treated as a number. And the general rule of thumb is, whenever I see a single equal sign in programming code, and this applies to every language, by the way, it is not an equal sign. So first of all, get that out of your mind. It's not an equal sign. It's an assignment statement, or an assignment operator is really the better way to say it. And the way that it operates is like this. Whatever is on the right side of that equal sign gets stored in the variable on the left side. So this is now in that spot in memory. I can access the contents by just simply referring to it by its name. That can be a number, or it can be a string of characters. The string of characters, right? So this is treated as text. This is treated as a number. I can do math with this. I cannot do math with that. Okay, this is a thing. That's very common in other languages. But when I look at this in other languages, and I'll bring it up in the try it editor here. Like if I was in C# and I wanted to store a number, I'd have to say int, And I want you to notice that it kind of also works in Python. So that's a whole separate story. But in Python, I do not have to declare what kind of data is going into the variable. I just stick it in there, and now it's that data type. Yeah, Alexis, I mean, yeah, you could think of it that way, but in a sense, it sort of is a pointer, but it's not really a pointer until we start dealing with objects and we have memory references. So that maybe is not inaccurate, but you could think of it that way if it helps you. But notice that, if I change a number to like 57 and change the name to Johnny, right, and I run it, it will output those. Right? And I can do both of them. And I could put them in the same statement if I wish to. So for example, I could say X plus Y. Will that work? No. Why? Because this is a number, and then it assumes that this is a number too, which it's not. Right? So we'll learn this as we get to the next lab. But if I had X and Z, and I tried to do math on it, that would work because they're both numbers. See, we went through the math in the print statement. If I want to take the number and append it to the text, well, then I would have to use my other techniques, right? And I would have to be really careful with how I do that. I think that's correct. See if I'm correct. There you go. So I have to use a joining symbol to make it work. So the default joining symbol in Python is this. Let's move on to the next topic. The next topic is converting an integer to a string. All right, let's start with this. What is an integer? Right, so coding people already know the answer, right? An integer, and it's one of those terms we use in math to scare people from math, but it's basically a counting number, like what you learned as a kid. 1, 2, 3, 4, 5, you count your fingers and toes. That's an integer. When I start to put a decimal number, that's a floating point number in Python. We will talk about data types, but for example, in this case, the number 3.5 is being converted to a string. They have this thing called a string function, right? So I can convert a number to a string. Why? Because it's easier to put it on the screen that way. Like if I want to use it as an output, it sometimes makes sense to convert it. So we can try that one if you want. But if I want to convert a thing that's typed as text at the keyboard to an integer, I can take a value that has quotes around it. So this is treated as text now, not a number. And then the int command converts it to a number, and then I can do math with it. Right. I think the best way to demonstrate this is to kind of show it in action. So we'll show it in action when we get to that exercise in the labs, by the way. The other thing is we have what we call string methods, which allow us to take strings of text. And I want you to see that there's a whole bunch of these, right? And don't worry about, memorizing these. We're just going to look at a couple of them. And it takes a string of text and allows us to do all these different things. And notice how long the list is. There's a lot of stuff in here. But one of the real basic ones is like capitalize. So for example, right, if I have a variable called txt and I put in this, and then I append to the variable with what we call dot notation, one of the string methods. So I take text, which is this, and then append to it dot capitalize. Well, let's take a look. I mean, you can kind of guess what it does, but what did it do? I mean, it's already run. It just took the first letter and turned it to capital. So in other words, if somebody types a sentence and didn't make the first letter capital, they typed a name and didn't put the first letter capital, this will do it for them. Could be good, could be bad. Another one that they have is upper. Guess what that one does? Doesn't take a genius to figure it out, right? Turns it all into uppercase. Now, there's also another one by the way, called lower, which turns it all to lowercase. And this is kind of a strategy, by the way. So when somebody is inputting information, for example, and you want to, I don't know, verify, I don't know, their password, for example. Password's not a good example because you have upper and lowercase, but maybe you're just trying to, recognize their name, but you don't want to compare the uppercase, lowercase, capitalized, not capitalized versions. You can just convert it to uppercase or lowercase and check one state. So this is what we call a string method that can manipulate text and do things automatically without the user being involved. And this is a very handy little thing. The ones that I think that we will use, I think, are the two that we just saw, and I think maybe capitalized, uppercase, and lower, I think are the three that we focus on. So we'll take a look at that. All right, so now let's take a look at the actual lab, see if we can replicate what's in the lab here. So we're going to keep rolling on this, and it says requirements. Add comments to the top of your file, including the following: name, class, assignment, and due date. Okay, we already have our thing open, right? And I kind of already started the process. So let's see if we can update that. So I got the name. Guess we need the class. So we'll just call it Python programming. Module 1, lab 1, and I think they wanted the date. Today is 1/21/2025. So step 1 of the lab is complete. All right, and this is how you should proceed, right? You should read top down through the instructions, and as you're doing it, complete each test. So that part's done. See how easy that was? Won't always be that easy, but sometimes. Next, prompt the user to enter their name and output the following. All right. A greeting in the following format. So hello, whatever. The length of their name. So we didn't learn about the length function, but I will show you that one. We'll convert it to uppercase, convert to lowercase, and then find one more method from the documentation and use it to output in the following format. All right, so we'll handle that last one last. We'll figure one out that we can use. But let's start with the very first thing, because we want to basically mimic this screen. And all of the labs, by the way, will have an example output so you know what to shoot for in terms of what it should look like. All right, so let's try this. Let's create an input statement that says, please enter your name. So I'm going to come in here and I'm going to close the little console window here for now. And you know what? We're almost there. See, the benefit of having already kind of done some of the work, I already have it. And you know what? I'm not going to call it username. I'm just going to call it name. All right, so please enter your name. So step 1 is complete. All right. Next, we wanted to say hello with your name and an exclamation point at the end. So let's do that. So I can change welcome to hello. We'll put in the name, another comma, and then at the end, and I want you to notice I have to put double quotes in there to get the exclamation point in there. I'm going to get rid of this statement here, or you know what? I'll do the other approach. I'm going to take the comment mark and just put it at the front of the line. Oops, here, sorry. And it makes the whole statement irrelevant for now. So, and in fact, I'm just going to move it down the screen a little bit. Let's get it out of the way. So let's see if this first part works. So I'm doing Control S to save, and I'm hitting the run button. Right. Please enter your name. I have to click into the console to be able to type, by the way. And I'm going to type my name. All right, that worked. Okay, I see one problem. You guys see the problem? I don't want a space at the end. That looks ugly, right? So how would I fix that? Well, whenever I use the comma to concatenate, it will always force a space in. However, if I use a plus mark instead here, which I can do, it will not. So Control S to save. We'll run the program again. Click in the console, type my name, press enter, and there you go. And hopefully that's working for everybody. All right, so that's the first little exercise. All right, let's see what the next thing is. Oh, so we have to learn about the length function, and we didn't look at that one. Why don't we go back to this W3 page here? All right, and we want to go back one screen. And somewhere here, they have the, I thought it was in here. Okay. I don't have it listed, but I can just show it to you. So if I have, for example, and I'm just trying to think of like what's the easy way to do this here. Pull my little cheat sheet over here. The length function basically operates like this. And first I'm going to do a little demo on it. So if I take length and then put in either a variable that contains a string or type in a string literally, and then I store its output in a variable. So here's an example. Right, so be mindful of the fact that this is an example at this point. So you don't necessarily have to type it in. But what's going to happen here is it'll prompt me again. It'll say hello. And then I'm going to take ASDF, right? Why? Because that's where my fingers landed in the home row. Length returns a value. And if I hover over it, and this is kind of interesting, it shows you that it's a function. It tells you what it returns. It returns the number of items in the container, which is how many letters. It will store it in X and then output it. So watch what happens. Here we go. Please enter your name. All right, and I'll type. All right, so it says hello. But then it read X, which is reading the length of the string and then outputting the length, which is a number. So it's outputting a number. Right, but what we wanted to do is output the length of my name. Okay, so, all right, so that was like the primitive example. So here comes the solution. So we're going to say print. Yeah, and I can do it inside the print statement. And what was the output screen supposed to look like? Because we can look there and say, okay, so it's going to put my name on the screen, some text, string length, and some text. Right, got that pattern? So that's what we're trying to recreate. So what I'm going to say here then is, okay, we want the name first. We'll say name plus the length of name. That's going to return the number. And then we're going to concatenate. And I want to control the spaces on this. So we'll say name. I'm trying to think. All right, so it's going to like kind of mess it up a little bit here. So I'm going to go name comma because that's going to add a space. We're going to name space a number space is, okay, that doesn't make sense because it says Patrick is, so it should be name, right, and I apologize for waffling on this, name plus space is space plus, okay, for me it's going to be 5 and then a space characters long, right? See how you have to kind of like think through that whole process, right? And so even though it's a very simplistic output, there's still a little bit of thinking that goes with it. Okay, so here's the thing. If you screw it up and there's like missing a space or has too many spaces or the words aren't where you want them to be, you just re-engineer it. Right. Welcome to programming, folks. So please enter your name. Typing my name. Oh, it doesn't like it. What did I do wrong? Yeah. All right, so this is not working because of the format, and this is really kind of fascinating. Okay, so what's happening is I'm trying to add a number here. Go back to the example I used before, and I'm using the concatenation symbol. So it wants to take the number and add it to my text, which is like, that doesn't work. You can't add a number to a string. So here's where it gets weird. Now I'm going to take that number and convert it to a string. So now I'm going to wrap another set of parentheses around it. So the number is going to be converted back to a string to put on the screen. And this is kind of a very important takeaway. It's weird, but important. So a number, if it's going to the screen, has to be converted if I use this concatenation symbol. I'm going to show you an alternate way to do this, which I like better, by the way. But let's get this to work first. So you see that? The length function returns a number. We need to convert that number to a string, and then I can join it with the other strings. All right, so running it. Please enter your name. Spell my name right. And yes, it is 5 characters long. Okay, a couple other little weird takeaways here, right? So when I'm using the plus sign concatenation symbols, you notice that I'm like putting spaces here, like in all these spots. Those will never display. I'm doing it for the comfort of my own eyes. I could write it like this, and it would still work, but it's harder to read, right? So that's why like programmers will usually space stuff out. The stuff that's inside the quotes, these will literally display. If I omit these spaces, in fact, let's just do it really quick so you can see what I'm talking about, right? If I run that, just type in a bunch of letters, doesn't matter what it is, right? Notice how the is has no spaces around it now. Hard to read, right? So I would manually come back in here and add those in. Might be a little bit of trial and error as you get kind of used to this. And folks, that's quite okay. There's another approach that we can use that I think is kind of interesting. And I'm going to demonstrate it. This is actually a topic for one of the later labs. But it's a technique called string interpolation. Except I have to sound it out as I'm typing it because otherwise I don't type it right. But it's called string interpolation, or some people just call it F string. C# people, you'll recognize this because it's very similar to C#, but we use a $ sign in C# here we use the letter F. So for example, I can do a print statement and I can put an F in there and then a set of double quotes, and then I can just type like I normally type, hey, and I want to put my name in here. So instead of like getting out of the double quotes, concatenating with a comma or a plus mark, I can just use curly brackets and drop the variable name right into the double quotes. Or what, whatever your message is. Right? Remember, this is an example, not really part of the assignment. So I'm just typing in nonsense letters and then, hey, ASDF, ASDF, ASDF. You are very cool, sort of. Right? But notice with this technique, you put the F at the front, and then I can drop the variables right into the string and not have to worry about engineering plus marks and commas. This technique, it's called string interpolation or F string, is I would call it the most modern way. Most modern languages have this tool now. We call it string interpolation. And in most cases, this is one of the better ways to go for doing output. It really is very situationally dependent. But for example, I could also, and this is why I like it, by the way, could I do this? So I should pose it as a question first. Could I put the length of name would this work? Okay. Lay your money, lay your bets down and see if it works. It does work. And so another reason why I like this a lot, the string interpolation does the conversion for you. It also makes, like when you're composing your output, it makes it a lot easier to kind of do that. And Dale, it says, did you declare name as X? No. Isn't that interesting? Right. And all right. So this is, I'm going to leave both versions in here, by the way, but I think you should experiment with all three. So there's the comma concatenation approach, add spaces, sometimes good, sometimes not, right? Here good, here not. The old school way where we manually force the spaces in and use plus marks, convert our numbers to strings for output. Yeah, totally works. Fine approach. F string or string interpolation, where you build your variables right in and conversion is automatic. You can see why that's a really popular modern way to do it, right? And maybe the ultimate recommended way. So there's three different techniques here that are all kind of put in place. All right, so completed three of the lines. Now we need to convert to uppercase, to lowercase, and capitalize. All right, so these we've had a little bit of experience with. And what I would suggest is that we use a simple approach, right? I don't want to take the name that somebody typed in and change it and store it in a variable and then output it. I'm just going to do it in the output alone, and I'm going to use the F string method to do it. So I'm going to say print, and what's uppercase? Okay, uppercase colon is what they're doing. So I'm going to do these all with F string, right? So there's my double quotes, and I'm just going to say uppercase colon space, and then, well, I want to uppercase the name. Do you guys remember how to do that? Yeah. The way that it works is you append it to the end, and I would just say upper parentheses like that. Let's test this to make sure it works. All right. Here's my name. Yeah, it works. All right. So if we want to do lowercase, a simple copy paste, and then change that to lower. Once again, I'll run it just so you can see. And then what was the last one? Capitalize. Well, all right, I'll make sure I don't type it in with a capital then. So I'll paste that in again, and we'll just change this to capitalize. And notice, and I want to show you that again, right? As I was typing that in, I just hit the first letter, capitalize is highlighted. I just press enter and it drops it in. Isn't that slick? No, it's not cheating. It's called working smarter. Why? Because if I was to type out capitalize, I might have to think about how to spell it. It's in the autocomplete list. It's already correctly typed. That's the one I want. And I just press enter. Done. Right? It keeps me from making typos. Right? So that's the other advantage of that. All right. Let's go ahead. I'm gonna minimize my console window here so you can see the whole darn program now.
Also, you should probably change the uppercase. You have it repeated 3 times instead of lowercase and capitalize in
no.
code. I'm just super fast.
Details. Thanks for spoiling my fun. So there we go. Thank you for catching that though, because yeah, right, that's the problem with copy pasting. All right, so now I'm going to go ahead and enter my name, and this time I'm going to enter it all. Well, how about let's do it really weird. I'll do like a capital S at the end, And actually that was to kind of prove a point too. So if I type in a capital S at the end, go to uppercase, that makes sense. Lowercase, that makes sense. Capitalize, it eliminates that capital S at the end. Isn't that interesting? Pretty slick, right? One thing that, and this is kind of an interesting side note, right? Python is very, very elegant at contending with text compared to a lot of languages, and very intuitive, and therefore super, super powerful, and explains why Python is used as the primary language to develop AI, because of its hyper flexibility in dealing with language components. It is really super slick in many different ways. Now, one little thing that I'm gonna kind of throw in here, right? And I have this from my previous iterations, and I'm going to kind of throw these in at the bottom just for the sake of it. All right, the first thing I'm noticing is I just pasted in this really long line of text, and now it's like scrolling from left to right, and I can't see the whole darn thing. All right, so here's one tip. If you go to your view menu and hit word wrap, it fixes that. Notice it's still all on the same line though. Yeah, seeing that? But okay, so this is the length function, right? The string function, just a little explanation. So I'm just copying those over. We also have this terminology that we throw around, and I just want to be sure that you guys are clear on this. I'm not sure why that went down there. Oh, because I left that in there. Function, so like the print command, or whenever you see a command with parentheses, that's a function technically. When functions are built into other objects, excuse me, we call those methods, right? We'll learn about all the terminology. A couple of other important key takeaways here. Whenever we work with Python, when we put one command on a line, that's what we'll execute. I would not want to add this print command after it. If I wrote Java or C# or JavaScript, if I had a semicolon in this spot, I could add another line of code there and it would work. In Python, it will not work. One command at a time, one on each line. That's a little weird, right, if you're not used to it. But folks, this is our first lab. All right. Now, please notice that when we do these labs, like I'll have the instructions for each lab, but it says don't submit your work here. You submit all your labs together. I will demonstrate how to do that. We are at the point now where I do want to take another really short break. We're going to make this one like 3 minutes, and then we'll come back. I'm just going to pause the video on this one instead of stop it. So I will see you guys in 3 minutes. All right. Dale pointed out the fact that we missed one of the steps, which is to pick another method to use. And I was looking at these two as being kind of nice ones. So choose one of these, but the application is fairly similar. I'm going to choose swap case. So I'm going to do this. I'm going to copy this line to start with. And then I'm going to say swap case. And then the keyword is swap case. And so let's take uppercase letters and make them small, and lowercase letters and make them big. Right? And that should be kind of interesting. So I'm going to go ahead and run that really quick. So I will intentionally add more than one capital letter. The first and last are capital, right? And notice how it switched them. So very, very exciting for sure. All right. And then I think there was one other piece that maybe we missed, and I'm trying to remember what that was. No, I think we've got all the points here. Right? We hit all the pieces. All right. We're going to move on to the next lab. And so what I'm going to do here is I'm just going to hit the next button, go to the next lab a little bit. Oh, sorry, not the video, but the next lab. Now we're going to start talking about math, and we don't have a huge amount of time left, but some of the stuff that you'll notice here, sometimes we'll repeat some of the information that we've covered some of this already. So I'm going to try to focus on the parts that we haven't talked about yet. So we already know how to get input from a user. We've already worked with F strings, which are pretty interesting. I'm just going to review this input conversion here, right? So we looked at this before too, like where you bring a value in and you can convert, for example, a number to an integer. This is kind of a weird one. So I'm going to actually show you this one. But if I take the number 3.5 and convert it to a counting number, which is like 1, 2, 3, 3.5 would basically truncate the 0.5. You might think it would round it up. It does not. It just drops it. It just only takes the whole number. Right. So that's the one aspect. The other thing is converting a string. So in this case, this is a string, something that somebody might type at the keyboard, and then it converts it to a number so that we can do math. Now, the grand goal really of this second lab is to talk about math and how to use math in your programs. And we're going to look at first like the math operators that are available. So like, as you would anticipate, plus and minus are plus and minus, right? So if I write like 3 plus 5, it's 3 plus 5, right? Remember, the equal sign is that oddball. That doesn't mean equals, right? That's an assignment operator. So plus and minus, addition, subtraction. Here's some examples. Multiplication is the asterisk, so the shift of the number 8 key or over to your number keypad if you have one, right? So not the X, but an asterisk. Division is the forward slash. It's on the same key with your question mark. That is different than the backslash, which goes the other way, right? And that's above your enter key, right, typically. But then we have these other 2 or 3 weird operators that take a little bit of getting used to, especially if you're brand new to programming. If you've programmed before, this will resonate. This is stuff that you probably have learned before. We have what we call the modulus operator. So what this is division, but it gives us only the remainder. And this one I'm going to demonstrate. So think about this. If I divide 5 by 2, what's the answer? Right. You can like do your longhand thing, but 2 goes into 5 twice, right? How much is left over? 1. Yeah. And that's what we're looking for. So modulus gives us the remainder is what it is. There's also what we call floor division. I'm going to show that one. That's a little weird too. So normally, if I divide 2 into 15, what's half of 15 basically? Well, the answer is 7.5. So if I did, for example, if I did regular math, it's 7.5. If I do floor division, it gives us the answer without the remainder, without what we call the fractional portion of the answer. It gives us how many, the nearest whole number, that fits. And in this case, 2 goes into 15 7 times. It ignores the remainder. Floor division gives you the whole number answer. Modulus division gives you the remainder. You're going to ask, why on earth did they invent that? Believe me, there's reasons. Actually, the original reason they invented these mechanisms is to learn, to teach a computer program how to make change. That was the original driving force. And it's a combination of floor division and modulus that gives you that, by the way. The other operator, which is weird to Python, is an exponent symbol. So like if I was writing, for example, code in C# or Java, and I want to say 2 to the 5th power, I have to use functions to do it. In Python, I just use two asterisks together. So if I want to take a number and square it, right? So 2 to the 5th power, which is the same as that, is 32. So Python allows us to declare exponents with this double asterisk operator. The only other language I can think of that uses an operator to do it is Visual Basic, and they used to use the caret symbol on that one. Maybe Fortran had that too. I forget. It's been a while. but that's not probably a language that you're ever going to work with. But these are the basic math operators that we're concerned with here. And we are going to do, basically a little bit of practice with that. So we're going to write a program that basically does this. We're going to prompt the user for a whole number twice, store the values in variables. Okay, so we're going to have a reassignment to make each one of those a string value of what was entered. We're going to use F strings for output, and then we're going to output the following using, and that doesn't really make sense. Output the following using A for the first operand, A for the first operand and B for the second operand. We're going to do the sum, the difference, the product, the quotient, the remainder, the power, and the floor quotient. Got all that? Right. Don't stress out on it. I will demonstrate all of it. Output the results of all these expressions that we see below. So these are more complicated ones. This is where we're going to learn about order of operations. Wherever they say have a caret symbol, this is assumed to be an exponent, by the way. And hopefully it will look kind of like this in our output. Okay. Couple things that they note here at the bottom. It says Python is strongly typed, meaning we need to be aware of the data type being stored in a variable, because it will sometimes dynamically adjust the math based on the data type. But the fact that it's dynamically typed, and this is really, really weird about Python, very different than other languages, aside from JavaScript. I can declare a variable and put a number in it, and it can be an integer. Or I can take a variable and drop a floating point number, and it'll be a floating point number, meaning with decimals or fractional pieces to it. Or I can have a string of text and put it in a variable. Then I can take that very same variable and switch it to one of the other data types dynamically. So in one statement, I can say A equals, chopped liver. And then I can say A equals 5. And then I can say A equals 5.5. And then I can say A equals hello world. And it all works. There's no other language aside from JavaScript that can do that. Well, there's a couple, but those are the main two that can do that. They're dynamically typed, meaning the data type of the variable changes automatically depending on what you put in. And what you guys will discover as we move forward is variables in Python can literally hold anything. Everything from simple numbers and strings up to very complicated, complex objects. Right? And this is one of the reasons why people like using it and why some people hate using it as well. Because, if you're used to the traditional approach of declaring a data type, and it's like, oh my God, this is flexible, this is scary, you don't know how to work with it because it's too powerful. However, what that allows for, and I say this with a lot of intent here, is that you can do some really crazy things with Python because of it. And sometimes you can just guess at the syntax and it just completely works. And that's one of the other reasons why it's used for AI. All right, let's dig into quoting this, or to coding this, excuse me. And I am building it from an example I have on another screen here. So one of the things you guys will learn is, I have everything's pre-coded, and to kind of accelerate the process here, I'm going to either copy paste or borrow heavily from what I already did. So the first thing I'm going to do is in my module 1 labs folder, I am going to create a new file. So we're going to start with a fresh file. I'm going to name it mod 1 lab 2 .py. Right. I'm just following my own naming convention. You can name stuff however you want. It's on you to remember. If you want to put your name at the top, say name, etc., that's on you. Right. I'm not going to do it. First thing we want to do is we want to prompt the user for 2 whole numbers. Right. So I'm going to first, and I'm going to copy paste this, and I'm doing this for the sake of efficiency here. I want you to notice first I'm declaring a variable called A. Why? Because they told me to. That's going to take my input. So I have a regular input prompt here. It's text, please enter an integer. And I always argue whenever you're getting a user instruction, you can't count on the fact that normal people know what an integer is. You should, right? Like you should learn that in like second grade or something, but people don't remember, right? It's a counting number. So I say a whole counting number. That input is coming in as text. To do math with it, I need to convert it to an integer. So I wrap the whole input statement with another set of parentheses, and I run the input function over it, which converts it to a number and stores it here. Whatever's on the right side of the equal sign, whatever the result of that is, will get stored on whatever's on the left side. This is an assignment statement. It's not for math. I'm going to ask them to enter another number. I want you to notice the difference here. Here, I'm not converting the number. So another option is I could just have them type it in as text. It'll land here as text. And then I can write this statement. And this is where that shows the data type flexibility here. I can then convert that to an integer and store it in the same variable. So it comes in as text, gets changed to a number, it gets put back in the same variable. Very weird. But this is Python. Hello. You can do it in Python. Python doesn't care. I would say the first approach is probably better, but this approach works too. This is easier for you to write, either approach, but I'm just showing you both so that you know. Then I'm going to go to an output statement just so that we can verify what we input. So I'm doing an F string with string interpolation. I'm going to say A is, and we'll see if the number is correct, and B is, and we'll see if the number is correct, and let's test it just to be sure of what we're doing here. So please enter an integer. I'm going to put in 1, and then I'm going to put in 2. Okay, A is 1, B is 2, we're good. All right, well, you know what, as I'm doing this, and I'm just going to kind of throw this out there, what if I wanted to put a blank line in my program? Well, you could just do an empty print statement. So sometimes I do this, and this is maybe very primitive, but I do it from time to time. I put in empty print statements just to create a little space in my program. So watch the run again. Okay, enter an integer, 1, 2, and notice I have a blank line above and a blank line below. A little easier to read, right? Yeah, a little bit. Okay. You don't have to do that. I'm just showing you, just so you know. Next part of it is to start doing some of the math operations that they asked us for. So I'm just going to label this section, right, do the math. And unfortunately, folks, programming involves math. And, I know people fear math. You should not fear math. What I always tell my programming students, yes, \n does, but we haven't hit that topic yet, Alexis. That is coming, right? But what I always tell my programming students is, you know, when it comes to math and writing code, if you're a professional programmer, you'll either be provided the formulas that you need by an engineer, a scientist, actuary, or, you know, whatever, or often you can just Google the formulas. You know, so for example, like over at Gateway, I teach, you know, similar stuff. And one of our exercises is the surface area of a cylinder. All right, well, I don't know that formula. Well, of course not. Just Google it. It's there. You know, it comes back really quick. Your job then as a programmer is just to convert the formula into Python, right? And that takes a little practice, but it's not that hard to do. You know, not a bad job for AI, really, right? When you think about it. All right, let's do a couple of different approaches here. So what I think is the preferred approach is that you simply do string interpolation through all of this, but you might opt to do it a different way. So for example, for a sum, I just say sum colon, I put the math equation right inside the curly brackets, and it will execute. I'll do the difference right away too, but this time I won't do string interpolation. I'll actually create a variable called difference and then subtract B from A. Then I will write the output statement, to display it. Let's just do this part so far. And I want you to see that this is okay if you do the math in one step and then output the result in a separate step. That's okay. That works, right? Um, the one thing I'll say about that, I'm putting the numbers 3 and 2, right? And you'll see the sum and the difference. The one thing I will say about that is the one reason you might not want to do it this way is by storing it in memory, because when I create a variable, I'm storing it in memory. If I'm never going to reuse that value again, why store it? You're wasting memory in the computer program. Your program will be a little slower because you're storing a value. These are like weird little considerations programmers make. All right, we're storing one number, not a big deal. But if I did this like 10,000 times, that becomes a big deal. It chews up your memory, makes your computer run slower. If you're just executing the command without needing to store the value, you can just brute force it like this. And this is wiser to do for speed of the application. All right. So if you haven't figured it out already, the next two are really easy, right? You can kind of just take that sum statement and repeat it. So the product, multiply, just change the sign, right? Quotient, change it to a forward slash and divide. Very simple. All right. Now we need to do the one that's kind of goofy, which is the modulus. That gives us the remainder, right? So I'm labeling it mod so you see it, because this is new for some people if you've never coded before. And chances are when you do like even like advanced math at school, they never talk about modulus unless you get into like weird discrete math and stuff. But in computer programming, this is a thing, right? So we're just looking for the remainder here. We're also going to try the floor quotient, or the floor division, and the powers, and we'll do it like this. And I know I'm moving quick, but I'm looking at the clock and I want to finish all of the labs before we leave here tonight, right? So you guys have completed stuff that you can turn in. All right, so we did all the equations, right? Let's run it and make sure that it works. We're going to test it to make sure it's correct. One thing I also always tell my programming students is, all computers come with a calculator built in. And whenever you do mathematical formulas, you can actually try them in a calculator to make sure they work, to make sure that what you're typing in as code is coming back correct. A calculator is one tool that you can use. And when you do more complicated things or repetitive calculations, you can also use a spreadsheet as a tool to verify your work. Whenever you're coding and you're putting math in, you need to make sure that the output of your math is absolutely correct. Don't take it on faith that you set it up correctly, because I will assure you, if you do that, you will fail. Right? You will omit something, or oh wow, I needed the decimal on that one and it didn't do it. That becomes a whole separate thing. All right. So let's do some values here. I'm going to put in the number 10 and the number 5. Okay. So increase the console size here. Sum is 15. Let's look at the whole thing, right? A is 10, B is 5. Sum is 15. Yes. The difference is 5. Correct. The product is 50. Sure. The quotient. So if I divide 5 into 10, it's 2. You guys notice that it did a floating point number on that? Interesting. Automatically. I didn't tell it to do it. It just automatically converted. Right. The remainder, well, 0. 5 divides into 10 evenly. Okay. So we'd have to test it with a different number. If I take 10 to the 5th power, it's 10,000, and that's correct because 10s will always just add zeros when they're power, so that is correct. The floor quotient, if I divide 5 into 10, yes, 2. So all of it's working correctly. Agreed? Yes. Let's keep adding to it because we have some other pieces. The other thing that they want us to do is to put this stuff on the screen. So this is pre-provided, right? But I want you to consider here, what are they really saying? A parentheses B minus A. Are they really saying A in parentheses times B minus A? That's what they're saying. So it's up to us to convert these formulas. What might be helpful, and I'm just kind of putting this out there as an idea, right, is you can take all of that text, bring it over here and paste it in. Yeah, it's going to sort of look okay, but if you forget what the formulas are, you can put like comment marks in front of it to turn it off basically until you build it, and then build it into your thing. What I'm going to do is, of course, I have this copy pasted, but I'm just trying to give you a strategy when you're working on your own. Sometimes it's helpful to take given information, paste it in, and have it there instead of flipping screens. Right? That's what I was mentioning before. So the first one converts to this. Notice how I put the multiplication symbol here. And let me ask you a question. Does it matter that I put the A in parentheses here? Okay. Mathletes, right? Well, yeah. Well,
Isn't
Anthony's
it?
nodding, and he is correct. Yes, it does matter a lot because the order of mathematical operations, if I omitted these parentheses, would multiply A by B first and then subtract A. By putting A here, right, this will need to happen, right? We'll do the subtraction and then we multiply. Really, it's waiting for that to happen, but otherwise it will break the order of operation. So the parentheses in math and in programming are highly important. Have you guys ever heard of this, right? PEMDAS, that should be an M, right? Please excuse my dear Aunt Sally, right? Which stands for parentheses, exponents, multiply, divide, add, subtract in that order. So whenever you see those like silly Facebook things like 3 times 4 plus 1 times 3 divide by 2 or whatever, if you use PEMDAS, you can figure all of those out. They're not hard, right? Just people forget the rules. You can look that up, by the way. Right. So that's the first one. Here's the second one. Do these come up with different answers? That's a really kind of interesting one. We'll find out. Then we have the third one. Fourth one. Yes, I am copy pasting all of them. And I know you guys are hurriedly trying to type them in. I can give you an alternate strategy. If you're racing to type this in, you can wait until tomorrow to watch the video. Or if you're really clever, if you're in Windows, you bring out your snipping tool and just screen capture that from Zoom directly and then type it in. I'm just giving you strategies, right? This isn't cheating, but I'm just trying to show you the correct way to do it and clever ways to keep up, right? Because I know I'm moving quick right now. My intent is not to lose you, but to give you the strategies that you need. All right, I'm going to go ahead and run this. And normally what I would suggest is this. I would suggest that when you're looking at these equations, if you want to do the due diligence on it, I would try to predict what the output of all of these would be first, and then run the program and see if you're correct. Right? And then that'll reinforce whether you know the math or not. The funny part about programming, you guys, is especially if you go on to higher levels, and I'm going to try to pick some weirder numbers here. So I'll do 12 and 7. So you can see the output. Let's just review. A is 12, B is 7, sum, difference, product, quotient. I take that on faith. I'd have to type it into the calculator. The mod, so the remainder, yep, that's correct. Right, 7 goes into 12 once with 5 left over. If I take 12 to the 7th power, apparently that's the number, you can test it. The floor quotient is 1. How many times does 7 go into 12? Once entirely, without any remainder. And then all those operations should give you this. Now, if you want to really verify your numbers, the other thing that you can do is you can take the values that they typed in, which were 3 and 2, and see if it matches up. And notice, oh, they wanted us to output text also. Well, I didn't do that. That'll be on you to complete. But let's try their numbers to see if we come up with the same thing. And I think it was 3 and 2. All right, so let's do that. 3 and 2 And then are all these numbers the same? I guess the ones I'm worried about the most are the ones at the bottom. 3, -3, 25, 45, and 7. 3, -3, 25, 45, and 7. Rock and roll. All right, so we're good. So one of your challenges would be to include this as text without having it execute the formulas. How would you do that? Well, I'll do one of them for you. So for example, you could just take this. Yeah, I just copied it, if you're wondering, right? There's the print statement. I can make it an F string. I can drop in that text. I put curly brackets around this part, close the double quotes, and then when I run it, and we'll do 3, oops, we'll do down here, 3 and 2 again. There you go. And I would suggest blank print statements to make it look nicer. So maybe I would put like a blank print statement here, and maybe a blank print statement at the bottom. We'll run it again one more time. Make it almost full screen. There's 3, there's 2, and there's the whole program. Right. Assuming you guys will fix these, right? Those are really easy to do. I mean, I could do it in like 3 minutes flat, but let's move on to the next lab. If you are running into any problems, by the way, I'm willing to stick around right when we're done recording, and I'll answer them and look at any of the issues that you're having, just in case you're going into panic mode and hyperventilating. Because I get that feeling, right? Because I'm kind of in accelerated mode right now. And it's not to try to lose you, it's just to try to make it as complete as I can. We're going on to the next lab. So I'm going to create a new file, mod1 lab3.py. Let's go to the instructions now. And I think I'm just going to hit next here. Hopefully it goes right to the lab. All right, it says we're going to practice using formatting fractional data, specifically when used in expressions. So this is where we kind of ramp up the math just a little bit. And first, we're going to find the percentage of a number. It's kind of an interesting little thing. Get 2 inputs from the user, an initial value and a percentage. Calculate the output and output the percentage of the initial value as a decimal to the hundredths position. So we got to learn how to do that. Then we're going to do this compounding interest thing where we have all these like fancy values, and it's like, oh my god, this is like math class and it's a word problem and I hate it, right? That's what's going through your brain right now. But fear not, I will guide you, right? The following pieces are all used in this formula, and yeah, this is how you compound interest, right? And it's not a simple formula. It is got exponents that are multiplied, it's got division, and it's a formula set up to basically, screw over the consumer when it really comes down to it, right? And that's why you really don't want to borrow money if you don't have to. And if you do borrow money, you're better off getting a house loan than you are a credit card, because home loans, the interest accrues monthly. On credit cards and other, types of debt, it accrues daily, right? Which is why credit cards are not a good idea. Not that we're making this a finance class. All right, so that's what we're going to do. So this is what the program is going to look like. It says this application takes a dollar amount and finds the compounding interest rate. So we'll put in the initial amount, the interest rate, how many times the interest is applied per year. So this would be a monthly accrual. And then how many years have elapsed. And then it will give us basically a result. All right, so I'm going to go through these steps. All right, and so like this is the kind of weird stuff that I do, and you do not have to follow this approach, right? So one thing I did, and I did this last time, is I took all those like little formulas and symbols and I just pasted them in to the program once again, so I don't have to flip back and forth. I have the formula, I have what all the different letters mean, and it's all right here, right? Don't have to flip back and forth. Right? So first thing that we're going to do is we're going to get the value, right? We'll get the string value first. So in other words, I'm going to have them enter what is the principal amount. I want you to notice I am not converting at this point. You guys picking up on that? There's a reason for that. Here's part of the reason for it. Right? So whenever we're working with, okay, counting numbers is one thing, but now we're starting to work with money. And because we're working with money, we're going to convert, and I should say this here, we are converting to a floating point number because it deals with money, right? And with money, we want decimal precision. It matters, right? But only the first two, right? But we want it to be a floating point number. So before we were converting to an integer, now we're converting to a float. So if I type in the number 1, for example, it will turn it into 1.0. Or if I type in 1.11, it will take it as 1.11. Okay. But we're storing it initially as text, and we're taking that text and storing it as a floating point. Could I wrap the float around the input statement? Yes, totally allowable. Right? I'm doing it as 2 steps to make it evident to you. Next thing that we're going to do is we're going to grab the interest rate. So I'm creating a variable called rate to store the value, and I'm prompting. So once again, they're typing in text. And why the percent mark there? Well, that's what they did in the example. I think it's kind of down, but there it is. Now we're going to take that and we're going to do a little bit of math. So watch what I do here. Very interesting. First, I'm going to take the rate and convert it to a floating point number. I'm going to divide it, notice, by 100. So this is to get it to be a percentage, right? Now, I want precision, so I'm not just typing 100. I'm typing 100.0. This is called casting. This makes sure that it stays a floating point number. I'm dividing a floating point into a floating point. That will give me a floating point number. That gets stored here. Remember, this started as text, and now it's becoming a number down here. Weird, but that's how Python works. Now we're going to compound the interest, right? And I want you to notice here as I do this, and I'll you know what? I'm just going to paste all this in because it's got description in it too. And I'm turning on word wrap so you can see it all. But this is my basic statement. So I'm going to come up with this variable called compounds. I'm going to ask the number of times interest is applied per year. I want to make sure that is an integer, right? If it compounds daily, what number would you type in? 365. If it's monthly, you type in 12. It's probably going to be one of those two. And I don't know why I had this stuff in here, but these are my notes from last time. Okay. All right, so I'm just going to get rid of that. It's irrelevant to what we're doing here. But that's how I opted to do it. You guys all good? Not moving too fast. Just a few more lines of code. All right. Now we're going to prompt for the number of years. Once again, we're converting to a floating point number. Okay. Why floating point? For precision. If I use an integer here, it would cast the result to an integer when I put time in the equation, which we do not want. I also want you to notice, and these are just weird little comments, I'm leaving like blank lines here just for the comfort of my own eyes. They are irrelevant to the output or functionality of the program. It just makes it easier for me to see. All right. Now we're going to take that formula. So here's the formula we're trying to recreate. And it's kind of in Python set up already. The problem is we have to convert like these weird letters to the variable names that we decided to use here. That's the challenge. All right, well, interestingly, I've done that for you. So here comes a new variable called accrued. That's the capital A. The principal, we're multiplying it against that weird formula. So 1 plus the rate divided by compounds, raised to the power of compounds times time. So that's the exponential notation there. And then finally, all we really need to do is put the results on the screen. So here's where we're going to start talking about, formatting in currency. We're not going to really go into this tonight. C# people, this will look really, really, really familiar, right? Okay, and this is the why. Just about every major programming language uses the same original C language libraries to do their financial formatting. Somebody wrote the code back in like the 70s or the 80s. And then every language that's followed is like, well, we could reinvent this, or we can just use the C libraries and have an interpreter for the C libraries. That's what we do, right? So the approach is very similar. So basically what this does is it says we're taking this variable, there's a colon, it just says, oh, here's the formatting. The formatting is 2 spaces after the decimal for a floating point number, and the $sign is just text, if you're wondering, right? Because we want it to appear as a number. We'll review this, but whenever you do financial formatting, this will be added to it, right? The most common type 2 digits for money. When you do the formatting, and this is important, it will round, right? So if it's over half penny, it will round up. If it's under, it will round down. Let's go ahead and run this. And what I'll do here, screenshotters, right? Want to quickly screenshot. You got 5, 4, 3, 2, 1, and I'm going to run it. Remember, you can always watch a video tomorrow. Enter the principal amount. Let's use the numbers in the example. So I have 10,000. Looks like my numlock is off. 10,000. 3.875, I think, was the amount. 12 times per year and 7.5 years. So the output should be 13,366.37 on the money. Okay, so that is the example there. Now, a couple things we want to talk about here. I know I did this really fast, but I'm doing it in the interest of time. The real takeaway here, this is a complicated formula. This is not like a low-level formula. It's not like basic algebra, right? This is exponential. Really, it falls kind of in the trig range when you start working with exponents like that, because it creates a logarithmic pattern on a graph. Once again, just keep in mind, don't have to be a math expert. You just need to be an expert in taking the formulas that you're given to convert it to Python speak. And, this already is kind of Python-like, where an actuary would write it out and the NT would be a superscript, and they might have the R appearing over the N, not next to it. It's like that kind of weird stuff. Takes a little bit of practice to do that, but you don't have to be a math expert to code math. You just have to be an expert at converting it to Python or whatever language you're working with. Another little sideline is, if you move forward in studying coding and you do it on the 4-year level, maybe the master's level, which once again, I would encourage you to do that, because the higher up you climb the educational ladder, the more money you can make with the skills that you're gaining. When I completed my master's degree, I had earned so many math credits, I can teach math on the college level. You know, it unfortunately goes with math. So I had to do 3 levels of calculus, discrete math, and yada 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 yada, like just crazy amounts of it. And at the time going into it, I was completely intimidated. And it's all about the quality of the instruction. I just was very fortunate and had a uh, very adept teacher at teaching me those topics. Um, and people pay you big money for math skills, folks. Right? Programming and math go hand in hand. They derive from the same place and from the same logic. Don't let it intimidate you. It's just another language for figuring stuff out. If you get programming, I'll tell you right now, you'll get math too. They're that closely related. All right, I'm going to end this video here. So the video stops now.